Akanksha and Nidhi.
Hi, my name is Rutuja Shivaji Dodkar. So, what is your topic, Akanksha?
Today I am going to present on the topic service-oriented architecture in cloud computing.
So, what is service-oriented architecture in cloud computing, and why is it important today?
Uh, a service-orient a service-oriented architecture or SOA is a software design approach in which applications are built as a collection of independent, reusable, and loosely coupled services. Each service performs a specific business function such as authentication, payment processing, or data retrieval. When combined with cloud computing, SOA becomes extremely powerful because cloud platforms provide scalable infrastructure, on-demand resources, and global accessibility. This allows service to be deployed, managed, and scaled dynamically. In today's digital world, where applications must handle millions of users and continuously changing requirements, service-oriented architecture in cloud computing provides flexibility, scalability, and efficiency. That is why it is widely used in industries like e-commerce, banking, and healthcare.
So, what are the key concepts and areas covered in the study of SOA in cloud computing?
This study covers a complete understanding of how service-oriented architecture works within cloud. It begins with the fundamentals of cloud computing, including its models and characteristics. It then explains the need of service-oriented architecture, its design principles, and architectural components. Further, it explores how service-oriented architecture operates step by step, and then technologies that enable it, and how it is applied in real-world systems. A detailed case study is also included to demonstrate practical implementation. Finally, it discusses benefits, challenges, and future trends, giving a holistic understanding of the topic.
So, what are the objectives of studying SOA in cloud computing and distributed systems?
The main objective is to understand how modern distributed systems are designed to handle large-scale data and applications efficiently. This includes learning about cloud computing infrastructure and how distributed processing frameworks like HDFS and MapReduce work. Another objective is to analyze system characteristics such as scalability, fault tolerance, and performance optimization. The study also aims to understand how services interact in a distributed environment and how cloud platforms support these interactions. Overall, it focuses on building knowledge of efficient, scalable, and reliable system design.
How does SOA improve applications design, and how does cloud computing enhance the effectiveness?
Service-oriented architecture improves applications design by breaking down complex systems into smaller, manageable services. Each service performs a specific task and communicates with other services using standardized protocols. This modular structure reduces complexity, improves maintainability, and allows independent development and deployment. Cloud computing enhances service-oriented architecture by providing a flexible and scalable environment. It allows services to be deployed over the internet, scaled dynamically based on demand, and accessible globally. It also eliminates the need of expensive infrastructure by offering a pay-per-use model. Together, service-oriented architecture and cloud computing create systems that are efficient, adaptable, and capable of handling large-scale workloads.
So, why did traditional monolithic architecture fail, and how does SOA provide a better solution?
Traditional monolithic architecture combines all functionalities into a single application, while simply initially it becomes difficult to manage as the system grows. Any small changes require deploying the entire applications, leading to downtime and increased risk. Service-oriented architecture addresses these limitations by dividing the systems into independent services. Each service can be developed, tested, and deployed separately. This improves flexibility, reduces development time, and makes scaling easier. Additionally, with cloud integration, these services can be dynamically scaled and managed, making service-oriented architecture more efficient and modern architecture solution.
What is the cloud computing and what are its key characteristics and service models?
Cloud computing is a technology that delivers computing services such as servers, storages, databases, and software over the internet. Instead of owning physical infrastructures, users can access resources on demand. And the key characteristics include on-demand self-services, allowing users to provision resources automatically, broad access network, enabling access from multiple devices, resource pooling, where resources are shared among users, rapid elasticity, allowing scaling up or down quickly, measured services, where users pay based on usage. And cloud service models include infrastructure. First is infrastructure as a service, which provides virtual hardware. Second one is platform as a service, which provides development environments. Software as a service, which provides complete applications like Microsoft 365 and uh, Gmail. These features these features make cloud computing highly efficient and suitable for service-oriented architecture implementation.
So why is SOA essential in modern cloud-based systems?
Service-oriented architecture is essential because modern applications are complex and require integration between multiple systems. Organizations often use different software systems that need to communicate efficiently. Service-oriented architecture enables this integration by providing standardized service interfaces. It also promotes reusability, allowing the same service to be used across multiple applications, reducing development and the cost. Another key reason is scalability. Cloud, cloud platforms allow services to scale independently based on demand. Service-oriented architecture also improves business agility, enabling organizations to quickly adapt to change. Thus, service-oriented architecture is necessary for building flexible, scalable, and cost-effective systems.
So what are the fundamental principles of SOA and how do they contribute to system design?
Service-oriented architecture is based on several principles that guide its design. Loose coupling ensures minimal dependency between services, allowing independent operation. Reusability ensures services can be used across multiple applications, reducing redundancy. Autonomy allows services to function independently, improving reliability. Discoverability ensures services can be easily found and accessed through a registry. Interoperability enables communication across different platforms and technologies. Statelessness ensures services do not store session data, improving scalability. These principles collectively ensure that systems are flexible, scalable, and easy to maintain.
So what are the core concepts of SOA architecture and how do they interact?
So the core components, including the core components include a service provider, service consumer, and service registry. The provider creates the service, the consumer uses them, and the registry stores their details. The enterprise service bus acts as a communication layer that connects service and handles routing and transformation. The message broker enables asynchronous communication, ensuring reliable message delivery. These components work together to enable seamless communication and integration in distributed systems.
So what are the different level of SOA in cloud environment and why they important?
Service-oriented architecture operates at multiple levels to ensure proper organization. The service level focuses on individual services. The application level combines service into applications. The enterprise level integrates services across departments. The infrastructure level provides cloud resources and the data level manages storage and data flow. These levels help manage complexity and ensure efficient system design.
So how does the SOA system work step by step in cloud environment?
The process begins. The process begins with service creation and description. Services are then registered in a registry. Consumers discover the required services and send requests using standard protocols. The service processes the request and returns a response. Cloud platforms ensure scalability and availability during this process. This structured workflow ensures efficient communication and system performance.
So what are the technologies support SOA and how do they enable communications and integration?
Technologies like SOAP and REST are used for communication. SOAP provides secure messaging while REST offers lightweight communication. WSDL describes services and UDDI helps in discovering them. XML and JSON are used for data exchange. ESB tools manages communication and integration. These technologies form a backbone of service-oriented architecture system.
How does cloud infrastructure enhance SOA performance and scalability?
Cloud infrastructure provides dynamic scalability, load balancing, and monitoring. Services can scale automatically based on demand. Technologies like Docker and Technologies like Docker simplify deployment and management. This ensures high availability, fault tolerance, and efficient resource usage.
So how does SOA differ from the microservices in architecture and implementation?
Service-oriented architecture focuses on enterprise-level integration, using larger services and centralized communication. Microservices use smaller independent services with decentralized management. Microservices offer faster deployment and better scalability, making them suitable for cloud native applications.
What are the real world applications of SOA in cloud computing?
SOA Service-oriented architecture is used in e-commerce for managing orders and payments, in banking for secure transactions, and in healthcare for managing patient data. It is also used in government systems and enterprise applications for integration and efficiency. These applications demonstrate its versatility.
How does online shopping system implement SOA in a cloud environment?
So basically the case study is on the system and is divided into services like authentication, product catalog, cart, payment, inventory, and shipping. Each service performs a specific function and communicates via APIs. This improves scalability, reliability, and system performance compared to monolithic systems.
What are the major benefits of using SOA in cloud computing systems?
Benefits include flexibility, scalability, reusability, cost efficiency, easier maintenance, and high availability. These advantages make SOA suitable for modern applications.
What are the challenges are faced when implementing SOA in cloud computing?
Challenges include governance complexity, security risk, performance overhead, testing difficulties, and dependency management. These require proper planning and expertise.
What are the emerging trends in SOA and cloud architecture?
Trends include cloud native service oriented architecture, serverless computing, AI integration, IoT connectivity, and multi-storage strategies. These advancements will enhance system efficiency and intelligence.
What is the overall conclusion of service-oriented architecture in cloud computing and its significance in modern systems?
To conclude, service-oriented architecture in cloud computing represents one of the most powerful and practical approaches for designing modern software systems. If we look at the complete discussion, we can clearly see that traditional monolithic architectures are no longer suitable for today's requirements. Modern applications demand high scalability, flexibility, and continuous updates. Monolithic systems struggle in such environments because they are tightly coupled, difficult to maintain, and hard to scale. This is where service-oriented architecture provides a major advantage by dividing applications into independent and reusable services. Service-oriented architecture introduces modularity into system design. Each service focuses on a specific function, and this service communicate using standardized protocols. This not only simplifies development but also allows independent deployment, testing, and scaling. Now, when service-oriented architecture is integrated with cloud computing, its capabilities are significantly enhanced. Cloud computing provides the infrastructure needed to support service-oriented architecture efficiently. Features like on-demand resource allocation, rapid elasticity, and global accessibility allow services to scale dynamically based on demand. This ensures that applications can handle varying workloads without performance issues. Another important point is cost efficiency. Cloud performs for cloud platforms follow a pay as you use model, which means organizations only pay for the resources they consume. Combined with service-oriented architecture's reusability, this reduces both infrastructure and development costs. From a design perspective, the principles of service-oriented architecture, such as loose coupling, autonomy, reusability, and interoperability, play a crucial role in building flexible and maintainable systems. These principles ensure that services remain independent and can evolve without affecting the entire system. We also discussed the architectural components like service providers, consumers, registries, and ESB. These components work together to enable smooth communication and integration between services in the distributed environment. When we look at real-world applications, it becomes clear that service-oriented architecture is not just a theoretical concept. It is actively used in industries like e-commerce, banking, healthcare, and government systems. For example, in an online shopping platform, different services like payment, cart, and shipping work independently, yet collaborate to provide a seamless user experience. However, it is also important to understand that service-oriented architecture is not without challenges. Issues, issues like governance complexity, insecurity, risk, performance, overhead, and testing difficulties must be carefully managed. These challenges highlights the need of proper system design, monitoring, and skilled professionals. Despite these challenges, the advantages of service-oriented architecture far outweigh its limitations. Looking towards the future, service-oriented architecture continues to evolve with emerging technologies. Concepts like the cloud-native architecture, serverless computing, artificial intelligence integration, and IoT are further enhancing its capabilities. These advancements are making systems more intelligent, automated, and efficient. In fact, modern architectures like microservices are derived from service-oriented architecture principles, showing how influential this concept has been in software development. So, if we summarize everything in one line, service-oriented architecture in cloud computing provides a scalable, flexible, cost-effective, and future-ready approach for building modern applications. It enables organizations to respond quickly to change business needs, handle large-scale data, and deliver reliable services to users across the globe. And therefore, understanding service-oriented architecture in cloud computing is not just important for academics, but it is also essential for designing the next generation of intelligent and scalable software systems. So thank you for your time and attention. I hope this discussion gave a clear understanding of the topic. I would be happy to answer any questions.
Okay, thank you.